a dashboard to interact with the semaphore contracts. So there are not any functionalities here. You can work with the semaphore. There is a demo app for Bandada as well, Bandada and semaphore. It includes semaphore, of course. And okay, this is like an arcade and semaphore, just to show you like the flow. It's like a database with like the groups and the members of the group, a backend with the APIs to interact with those groups. Now the block on the right is what you are going to build basically, or like what you will find in the boilerplate. And call the Bandada APIs to fetch Merkle proofs, which is not like the zero knowledge proofs. It's a Merkle proof, which is like the path from the leaf to the root that proves that a semaphore. And then the proof is sent to the backend, where the server can check if the proof is valid, checking if the Merkle tree root of the proof matches the Merkle root of the Bandada group, and of the proof matches the Merkle root of the Bandada group. And if the proof is valid, the server can run its logic, like authenticate. The proof is valid, the server can run its logic, like authenticate. They see in these projects, Bandada and semaphore with no particular constraints. Much. Okay. Guys?
Okay. Hello everyone, my name is Jaditya Gupta. I'm part of PSC team, currently working with TLS Notary team. So in this workshop, we will learn introduction to TLS Notary, bounties for the hackathon, and the plugins and development system. So this is the kind of workflow we will follow. So just introduction, some theoretical part of TLS Notary, a browser extension demo, and then the code part too. So first of all, what is TLS Notary? TLS Notary is a cryptographic protocol that allows you to transfer or unlock your Web2 data and give a proof or attestation to a third party. So you can literally prove that you have, for example, proof of Steam achievements to another website, for example, Epic Games, that you have achieved this achievement or you own these games. So it works on the TLS protocol, the Transport Layer Security Protocol, TSS, HTTPS. And it works in the following way. First of all, it's not the man-in-the-middle attack. So your connection to the server is still encrypted and private with TLS security. It's not man-in-the-middle. So how it works is you have a website, for example, a bank website or a government website, and you make a TLS connection with that, and you get encrypted connection with that website. So if Alice have to prove to Bob that she has, for example, proof like this much fund in her bank account, she has to get an attestation from a notary service, or she has to ask bank or use an API or OAuth or something like that. But with TLS Notary, she can make a proof and notarize it with the help of TLS, and Bob will believe it because Bob takes part in the whole process. So it's like Bob will have reason to trust Alice because he took part in the key exchange and all the process when the data was generated. So most popular use cases is like, and I hope most of the hackers here are on the right side, like the KYC provider, creditors, data archive, or blockchain oracle. These are one of the use cases that where you can use TLS Notary. So why TLS Notary? guarantees the data origin, data integrity, and data portability. Like I mentioned, you can transfer data from one website to another and prove it's authentic and has not been tampered with. With simple TLS, you cannot do this because in TLS, you use symmetric encryption between website and you yourself as a prover. So on your end, once you get the data, you can modify it, and Bob can question you that you modified the data. But with TLS Notary, you can't do that because Bob will himself take part in the key exchange and hold the process. That's the notary part. So this is like what I explained. Like normally, you have the symmetric encryption between website and the you as a user or Alice. And you can't prove it to Bob because Bob will not trust the data because it's the symmetric key. You can change the data on your end. Like basically what you do on your website. For example, you can do inspect element, change the data, and just send that data to Bob. You can't trust that. With MPC TLS, multi-party computation, we use Bob as a verifier, Alice as prover, and you together take part in the key exchange. But for server, it's still the same key. For server, it's just one user. He doesn't know if they are Bob or Alice. For the server, it's just one user. Nothing changes for the server. It's just for prover and the verifier. Since verifier takes part in the key exchange, he can take part in the data encryption and decryption, but he can't actually read the data. And Alice cannot modify any data because as soon as the data comes, it gets encrypted with both of their keys. So there's a mutual trust between them because no one can cheat each other. Alice cannot modify the data because as soon as it comes, it's encrypted. And Bob cannot see the all data because it's encrypted. But it's on Alice if she wants to reveal what kind of information. So Alice has the whole capacity, like what kind of information she wants to reveal. So that's where the ZK parts come in. So in this example, for example, Alice can, instead of giving her address, she can just say, okay, I'm not in US. And that's a valid proof because it's generated from the website. For example, if she wants to prove she's 18 plus, she can just give the ZK proof that proves that she's 18 plus instead of giving date of birth. So that's why it's a like lack of better term, it's called ZK-TLS2. So it has two parts, the TLS part, the notarization part, and the ZK part. Everything is open source, and the whole toolkit is in Rust and TypeScript. So we'll share the repo and everything that you can hack on. So we want to actually go in the whole live coding with all of you because we have only 20 minutes. But you can ask me questions later on that. So this is probably the most important link for you. It's a hackathon guide for each participant. You can follow. I would actually advise you to follow it completely before you actually start working on TLS Notary. So in the hackathon guide, you will have 3 examples, and I strongly recommend to complete all 3 of them so that you have better understanding of how TLS Notary works and how you can integrate in your project, or if it even makes sense to use it. So prove, redact, verify is basically you prove information from the website, you redact or hide the information, and you verify it to the third person. Same example, but this is with the Notary and the Rust example. Same, if you want to use, if you're familiar with Rust, go with this. And we also have the browser extension. If you're not familiar with Rust and if you want to do everything on the browser, you can use the browser extension. Same, prove, redact, and verify. Go through all of these 3 examples. The URL is there, and you will have better understanding of it. So I'm mostly work with plugins and browser extension TLS Notary team, so I will go more deep into that. So you can start with the browser extension demo, and there's a demo.tlsnotary.org. You just can go there, and it will guide you how to use the browser plugins. It's like a step-by-step game like that you can play. You can install the browser plugin, and it will guide you how to use the plugins. Again, this URL is also pretty important if you want to hack on plugins ecosystem. So some theory on how the plugin system works is, so TLS Notary plugin is a browser extension that takes the cookies and headers and all basically reads your connection with the website, and based on that, it will help you to formulate proofs. And you have to make the plugins or by yourself. So extension is like it will have the request and headers. It will provide you all the tooling that you need to get the data from the website and generate proof with it. But for each website, you have to write your own plugin. For example, if you are on Twitter and you want to prove that you own the Twitter account, you have to write a Twitter plugin for it. And the plugin system is pretty simple. I will go through that. It's basically follows a similar structure for each website that you can go through it. And it has basically 3 steps. It has 3 steps that you have to go for each plugin. The step 1 is to go to a website. Step 2 is to get all the cookies, and step 3 is actually to redact or verify and then generate a proof. Okay, so demo. Can I do live? If I have good internet, I will try to do a live demo. So this is the plugin that I made for the Axis Bank, which proves that I actually own an Axis Bank account. And then I can give the proof to a third party who might be a loan given application. So I hope okay. So I'm currently running my own Notary server locally, but PSE also has a Notary server that you can use. It's in the docs. You can use their server too. If your laptop doesn't have enough resources, just use the online one. Oh, my balance. So this is the browser extension, and as you can see, I have 3 plugins here: Axis Bank, Twitter, and the Discord DMs plugin. So I'm on Axis Bank. There are 3 steps: visit the website, get the cookies, and start the notarization process. So it will go through here. As you can see, it got the protocol, started a session, and it signs it, and then you can see successful notarization of request. So what does this proof actually have? The proof mainly has the information that I own the Axis Bank account and what is my name in the bank account. It hides some information like my account number. And so it's still working because internet is super slow, but I have the recorded version too if it fails, just in case. And it can show how much money I have. And if I want to apply for a loan, it can just show the loan, the money I have and how much percentage I can get through it. It hides the address or other crucial information if you want to hide. And it's on the user how much information you want to reveal or redact. So you can do all of this with the plugin system. And I hope some of you make real world application like this where you use actual services that are in India, or banks or KYC servers or anything that is being used every day, that where you can want to export the data to some other side. Where's the presentation? So I was going to demo the Twitter plugin example, but unfortunately, Twitter changed their API. So the plugin system for Twitter is failing. So even if you are trying in the docs, it might be failing. So don't worry, you're not doing anything wrong. It's just the Twitter changed the API. But there are more examples that you can check here. So just to play around, so to get the idea how plugin system works, there is Discord DM examples, Fitbit example. I already gave the Axis Bank example. I will push the code later. I just made it today in the morning. So it's not that hard to make, to be honest. Okay. So for you, there's also a tool that I wrote. It's called plugin generation tool. So plugin generation, writing a plugin is a tiresome task. You have to go through a lot of requests on websites and to see which requests are relevant and which response are not for the proof generation. So I made this project, TLSN plugin generation. It's a LLM-based tool. All you have to do is chat with this plugin. You have to tell what's the API or which website you are on, and it will gather all the requests and the response, and it will generate a code for you that you can later use to generate the plugin. So for example, we can visit Swappy. And I just have to, so in the official TLSN plugin, you won't have this chat window. This is added by me. It's still in early stages. So you can, wait a second, I have to start a server. Okay. So if you go with this plugin generation mode, you can go to any website. It will capture the current page, the API request, and the responses, and it will help you generate the plugin. So if you are stuck somewhere, maybe use this tool. So it will just ask you what's the API, and if you can, what do you want to notarize from this website. So for example, the website here is swappy.dev, and API is swappy.dev/API/. I want to notarize the response of the API. So it's basically like asking ChatGPT, but on the TLS and Notary plugin. The difference is you get all the benefits of TLS extension. So you can, instead of manually copy pasting the request and responses to ChatGPT, you can just do it here. Also, you can't post every response or request to ChatGPT. First, because of your privacy. Second, the request can be too big. For example, you request a bootstrap file, which is like 40K lines of code. There's no need for that. So it also filters all of these requests which are not needed. So it will only take the request and response which are needed for notarization. So in this case, it already it takes all of the requests, then it filters which requests are relevant to generate the plugin. So this is only needed if you are stuck with some website, or if you need help with plugin generation. So you can use it. It's for disposable for you guys. And if I go here, like basically it filters what is needed, what is not needed, and then it sends the response, and then it will generate the final code that you can use to generate the plugin. Like here. It told me what requests are relevant to generate the plugin code. So it tells me I need a GET request. The URL is this, and it creates a request for me, and I just send that. And then it will generate the code. So code will look something like this. If you are doing plugin development, we have also bounties for plugins based on how useful plugin is. There are rewards for that. So the core is you will have mainly 3 files: index.ts, config, and index.t.ts. So this file config.json tells how the plugin should work. The step 1 is like you visit a website like Discord, Twitter, or your bank, or your government website, or Aadhaar website, any website. Second is collect credentials, like you want cookies, or how can you collect credentials? Maybe there's a JWT token. You have to specify that what kind of credentials here are. Then the actual notarization and what kind of request you need to make. So this is just the workflow. And actual code goes here, the index.ts file. So you tell the step 1 where you have to go. Like for example, in this case, Axis Bank. And then step 2 was the collecting the cookies, or however the authorization is doing. In here, Axis Bank uses session tokens. So I'm just getting cookies, headers, and I'm creating a request what is needed and what is not needed. And then this is the parse part where you redact the information. Suppose you want to hide your bank account number, or maybe your address. So you can hide all of that information in step 3. It's up to you what you want to hide, what you want to reveal. And then the notarization part. And this is basically the workflow that goes here. So if you make plugins, you have to go through these 3 steps. And the code is available on example section of TLS Notary GitHub. Okay, where is it? So use cases. I hope some of you get inspiration from this. Identity is one big use case for TLS Notary. Like if you want to prove your identity to some other website, for example, you have your Steam achievements that you want to prove on, let's say, a statistics website. You can instead of using the Steam API, you can just give the proof that you have all these achievements, and it will be valid. Financial, like I demoed for the Axis Bank, you can do it for your bank, HDFC Bank, SBI, or any other. Or maybe you can write a plugin that can generate for any bank. I'm just giving you ideas. It's up to you. Social, I already said, gaming and other stuff. So it's up to you what you want to make on. Like any Web2 data, you can make a proof on it and submit to another website. Or you can make a service where people can submit the proofs, and then you do some kind of work with it. These are the bounties. These are also mentioned on ETHIndia, just to gather your attention, like on which part you want to hack on. So there's plugin and the best overall use case for TLS Notary. So up to you guys. And these are important links, so make sure to go through Hackathon guide. Docs are very important. And if you want to use the generation, the LLM one that I made, this is the third link, which can help you with the plugin development. Main code is in TLS Snow Tree repo, so all the plugins, the Rust code and the TypeScript and the libraries are there. That's it. Thank you. I hope you make something fun with it. Okay.
Hello guys, so my name is Yash and I'm an open source contributor at PSE. And today this workshop is about building privacy preserving polls with Macy. So the objective of this workshop is to understand what is Macy, how it works, why do we need Macy, and a quick demo on Macy Wrapper, which is a quick way of getting started with Macy. It includes our front end and the smart contracts. So Macy stands for Minimal Anti-Collusion Infrastructure. So it allows a coordinator to create private polls which have a few properties. The properties include the polls, the votes of the polls are only accessible for the user and the coordinator. So only the user and the coordinator can decrypt it. And the votes cannot be edited, deleted, or censored. Also, there is no way to prove to anyone that this address has voted in a certain way. Also, it guarantees correct execution, so it cannot produce false output. Now, why do we need private voting? So voting in general is susceptible to bribery and manipulation. But if the briber doesn't know how the voter is voting, how you are voting, so it doesn't make sense for him to bribe anyone. Also, we have seen in many occurrences that existing public votes influence the new voters. So if you see a lot of votes are going to a particular candidate, you are more influenced to vote on that particular candidate. So private voting eliminates all of these issues. So going through the architecture of Macy, so Macy consists of a lot of EVM compatible smart contracts, a couple of circum circuits. One of the circuit is for processing the messages, so processing votes and verifying the validity of the votes. The other circum circuit is for tallying the vote. It validates the calculation of the summing of the votes. And then there are a couple of TypeScript utilities. One of them is the CLI to interact with the smart contracts and the circum circuits. Another is a smart contract clone written in TypeScript so that the coordinator can create the whole state of the smart contract on his local computer. And the cryptographic primitives that are being used here are Macy keys, which are EDDSA keys. And the encryption used here is ECDH, elliptic curve Diffie-Hellman encryption. And the hashing algorithms are used here, and ballots. So the user flow is as follows. The user first registers on the platform. While registering, he submits his Macy public key, which is again EDDSA key, to the Macy contract. And then he will be able to send the votes on the existing polls or the new polls, the upcoming polls on the Macy contract. So that process include creation of a vote message. That message will be encrypted by a ECDH shared key, which is a pair of a random key and the coordinator public key. And then this message is signed with the Macy private key. Now, after the execution of this poll, the results will be verifiable on chain after the coordinator has processed all the messages and tallied votes. So the Macy votes have a few properties. Every single vote message has a nonce, which can be used to track the order of the messages. And it can be used to change your vote later. So you can submit the vote again with the same nonce as you submitted before. And the previous vote will be replaced by the new vote. Now, every vote can also have weights. So we can have like a election where every user gets, let's say, 100 votes, 100 voting power. And then while voting, you can select 4 different candidates and give them 25 voting power each. So you can have something like that also there. And anyone, irrespective of whether you have signed up or not, you can vote. But only the signed up votes will be counted. And proof on chain with the commitment hashes, and then he would tally all the votes locally and submit the proof again on the smart contract. So anyone who has voted or not voted can verify on the smart contract the validity of the tally of the vote. Now, here are a few links. I will share this slide on the PSE channel on the ETHIndia Telegram server. And so basically, there are like 3 parts which you can look at of the documentation. One is the Macy GitHub repository. Another is the Macy platform GitHub repository. And third is Macy wrapper, which I'm going to show the demo of. So Macy wrapper, let me show this demo. So basically, I will share this link on the channel, but you need to first clone the repository. 1 second. I don't know if you are able to hear the audio or not. Please raise your hand. Okay. I'll just play this.
Are separate. So it's more modular in nature, more secure, but it is a bit more complex to set up compared to BSC. Next comes EVM compatibility. So it's more similarities than differences. So both support Solidity, both are EVM compatible. There is one key difference when it comes to this Brave rundown opcode. So if you are trying to go for a random value, if you want to get a random value in your smart contract, you have to use Brave rundown opcode in case of Ethereum, whereas in case of BSC, you will need to use the block hash as shown in this slide. So that's a key small difference, but in other aspects, it's the same. When it comes to node operation, as we talked about the architecture before, so if you are a validator or a node operator, because BSC has a unified node, it is slightly easier to set things up, and it also supports built-in pruning. In case of Ethereum, it is dual client, and it's slightly more complex to set things up. Then we talk about proposer builder separation, or PBS. So in BSC we have in protocol PBS, whereas in Ethereum we have out of protocol PBS. So yeah, this is the gist of all the comparison in this table. I'll quickly go over the incentives or the price structures we have. So in case of incentives, we have 3 different programs. We have BNB Incubation Alliance and Most Valuable Builder program. I'll go over them very quickly. MVB program, it's an accelerator program.
Okay, 1 second. 1 second. Headphone settings. Where? Speak. External headphones. Okay. Hilarious. Now that's why I really don't like this headphone setup. Okay. So I will just mute this and do a walkthrough. So basically, you first need to clone the project, and I will add these links on the Telegram channel. Now, after you clone the project, you will need to download the Z keys. But for saving time, I'm just gonna copy paste the Z keys from my computer. But once you run the yarn download Z keys command, you will be able to download the Z keys required for building this project. Now, so I'm just copying that, and then after that, this is a scaffold ETH project which contains two packages. One is the hardhead package, another is the Next.js package. So the hardhead package contains all the contracts, and this is the Macy wrapper contract. Now the Next.js project, the hardhead project also contains the deployed contracts.json file. As you deploy more contracts, the contract addresses will be updated here. You will also see a deploy config better support.
Everyone, so I'm gonna be doing a quick talk on understanding ag layer. So before we talk about blockchain, I just want to talk a little bit about the history of internet and how internet started. So even in the internet all also started very fragmented. There were many different computer networks. It was all disconnected in the beginning, and there was no way to communicate with one network to the other network. So it all started in the fragmented way. You can see in this picture there was ARPANET, BitNet, CSNet, and Telenet, and what all other networks. So it all started in a fragmented way, and how are we trying to solve this problem? It was solved by unified protocols like TCP and IP protocol. They acted as like the packet transport and the common standards to deploy anything on the internet. So even the Wi-Fi, the video chat, the message chat, the email, everything on the web was deployed on two unified protocol, the TCP protocol and the IP protocol. Even in the Web3 world, we deliver the same sort of challenges. Everything in Web3 is fragmented. There we have scalability issues, we have security issues, and obviously we have UX issues. Now, how are we going around to solve it? The current scenario is that we can't beat the NASDAQ. Obviously, we want that anything in Web3 should be as big as possible in the Web2 world, because Web2 took over Web1, and we want Web3 to take over Web2 as well. But we see that in NASDAQ we have up to
hello username example. So in a few seconds it's building. So here, as you see, it sent a task saying that Hungry Dog 500 is what I want the operator to respond. And that is the task that is sent on chain. And you can see through Anvil that you have tasks registered and you have the response from the operator as well that you see here on the bottom left screen. The operator received a new task, hello hungry dog, and it responded and with the transaction hash. So we run this for couple of while, and this can be long running services, and it depends on you and how you want to define your AVS. So I'll go through the code on what this looks like. So as you probably remember, we have a create task, something that you, consumer, would actually need to create a task to interact with the system. And you have the respond task, which is how you would actually respond to the task you received. And this is the contract that you're seeing. And if you see in the respond to task, you have the reference checks on, am I supposed to respond to this task? Does it match my requirements? And is this actually something that I care about? And after all those checks, you see the message hash, which is, hello and the task name. That
this means misconception when we talk about interoperability, or when we talk about unifying the fragmentation. We just assume that we are doing it to a bridge, But ag layer is not just a bridge. Ag layer has many different components, one of them being pessimistic proofs, proof fabrication, and we'll see that in the next slide. But what it does is it blends most of the monolithic and modular chain to provide a UX that from a front end user's perspective feels like using a single chain. So you could send assets from a non EVM chain to an EVM chain seamlessly without the user knowing that you are using two different accounts. Now, how does it really happen? How does it really work behind the scenes? Is there are four potential different components that are involved in making this happen. One of them is pessimistic proof. The second is proof aggregation, and the third is unified bridge, which is what people think that ag layer is all about, just the unified bridge. And the fourth is fast interop. So pessimistic proof, starting with pessimistic proofs, that is a security layer that, for example, if I am deploying or if I am withdrawing 10 ETH, I cannot withdraw more than that, because the amount that is already there in a chain is the amount that has to be come back. So how does it work? Pessimistic proofs are very pessimistic in nature, in the sense that I am only trusting the chain I am on. I am not trusting any other bridge, and I am also not trusting the chain that I am getting assets from. So it works in a pessimistic way. The second portion of this is proof aggregation.
On chain, both the systems interact. What contract an AVS would need to write to work with EigenLayer, and how your AVS would need to work with its own contracts is up to you. So it helps differentiate what things we would need to work, what things an AVS would need to work with EigenLayer, and apart from that, whatever you would need for your AVS to work. And also you have deployment scripts, which will help kickstart your project for AVS. And you have the off-chain index.ts code, which I went over in more detail and explaining on how this works. And you have a task generator as well, which helps you to simulate traffic and show how your system is actually working. And we have local DevNet deployment steps as well. And if there are any more questions, happy to take. But yeah, that's pretty much it. Thank you.
Yeah. Do I need to wait for the timer to end, or I can start? And then I should start. Or I can start now. Yeah. Hey guys, so how many of you have heard about Polkadot before? Can anyone raise your hands? Okay, wow. So can you really deploy smart contracts?
Fundamentally, a blockchain dedicated to an app is an app chain, right? Or a group of related apps. But more importantly, what it enables is the criteria. App chain enables an app-centric business model. Let's say on a public blockchain, anybody can deploy a smart contract, right? And the users pay transaction fee that goes to the network. So what exactly is app getting out of it? Where is the business model coming in? Where is the revenue model being coming in? One has to bake in all the revenue model and the business model at the smart contract layer or at the Web2 front end. Can a framework be built at the blockchain layer itself which kind of facilitates business model? So that's where the app chain came into place. As I said, it enables a business model for apps. Another salient feature of app chain is about sovereignty, right? It's not only the creator, it's not only the developers, it's the community around it. The users of this app, they get a sovereignty, a community, a control over this app, a communal control over this app, right? So precisely the tokens, the governance tokens and the app chain tokens facilitate such sovereignty, and these two are the fundamental things what we believe that app chain brings to the table. Well, these are at the business level. How does it boil down to technical level, right?
Also enable L2 stacking, which is already live again, and in the next quarter we'll be also looking on to scaling Bitcoin as well. So that's something interesting that's coming up. So right now, why Starknet? So Starknet is the highest scale L2 right now, enabling mass production. This 410 is not currently updated. The current highest TPS is about 850 plus, and we offer the lowest cost L2, which is affordable to everyone, which is around now 0.001, which is going to decrease by another 2x in the coming 3 months, and going to reduce by another 2x to 3x in the other coming 8 months. The reason is we've got Stone Prover and we've got the Stone Prover and Stu Prover. Stone Prover, while comparing Stone Prover and Stu Prover is about 20x better efficient than Stone Prover itself, and that's the reason. A bit of what is Starknet. I think I'll share this much more in the QR code itself. Since I've got just 20 minutes, I'll just flow through. So why Cairo in the first place? So Cairo is a smart contract language that's used in Starknet, which is a provable language. Now why Cairo in the first place? Just giving a real life example. For example, say that there's a scientist working on how to save fuel. So he's looking onto best launch directory, best launch window, and best trajectory to go onto a planet. And engineers create an algorithm in Rust. Now the current issue is that, for example, in order to run this particular program, the Rust program, we will need a supercomputer in order to run this particular program. It's just a hypothetical situation here. So say that the supercomputer is only available in one country, which is our rival country. I don't think anyone would trust us, right? The proof will be invalid, and a regular computer is also being kept super honest over here. So the 5 features of Cairo is it creates provable programs, runs on top of Cairo VM. Syntax is very similar to Rust, inspired by Rust. Has a similar ownership model if everyone knows about Rust. It's strongly typed, it can be used outside of Starknet as well, and you do not know about anything with respect to ZK over here. So just reiterating, creates provable programs, proof of computational integrity, verification without re-execution. It's powerful and flexible language, prevents cheating and malfunction, and keeps a supercomputer honest as well. Now coming on to why Starknet. So everyone's aware of L1 scaling problem, right? So say that the block producer says that the new state is 42. Now what happens here is that the validators will have to execute this particular transaction in order to verify that this particular state was 42. This is the current L1 scaling problem. But say that this was done through Starknet. So say that the new state is 42, just as we looked into the previous example where we got the result and the proof as well. So here we've got the state, which is the result. Just comparing with the previous example, the result is 42, and we've also got the proof. But now what happens is that the validators need not execute the whole transaction again, but will just have to verify that particular proof, and hence the whole work is minimized by a lot. So this is just a graph between the execution and verification and how efficient it is. It's just a graph here. Just to
form an XCM message, and these instructions will execute on the same chain, and you don't even have to use something like a balances.
In the rest of the slides, I'll try to show how Supra containers give the app chain experience on a layer 1 blockchain for multiple app chains, for multiple apps. As well as I'll also try to show you and argue that it goes beyond app chains. What are supra containers? Fundamentally, it's just a group of smart contracts. Okay, there is no separate blockchain for an app. We are creating artificial boundaries for a group of smart contracts that are in the back end of any dApp. Okay, group of smart contracts typically belonging to a single application or a group of related applications. But that's not enough, right? We started out to give an app chain experience. That means we need to facilitate app-based business model and give sovereignty to the community. How do we do that? As we saw previously, we need to fundamentally break that down into these primitives. That means how do we realize custom gas token? How do we make the container admins set their own gas price? How do we enable approved or gated deployment of smart contracts? And more importantly, how do we enable localized fee markets, right? So the implementation is work in progress, and it's we have put out containers in our roadmap. It will come soon on our testnets and mainnets.
And then we just increase the counter. Same goes with get counter as well. These are the interfaces similar to how it's in Solidity as well. We implement these so that it's just a standard way of how we could use it for integrations with other dApps as well. So here's a pretty much a whole contract on how you can explicitly have explicit interfaces, and this is like the nomenclature of writing a simple contract. I will be showing, so I will be tagging all the resources at the end. And also if you have any questions with respect to Cairo, feel free to come by our booth and I'll be able to help you out there as well. Just skipping this as well. So events, I think I'll just skip this for now. So we use dispatches for now to doing to do contract to contract call. So we use something called dispatches. So we say use super iData dispatcher in order to in order to call this particular call or interact with this particular function. We say use super iData dispatcher and dispatcher trait, and we put in the address, and then we just access the dispatcher and access this particular function in order to access the data from that particular contract. Just running through quickly. Okay, let me just come to the resources part. So we have ASDF, we have Scarb. Scarb is like the package manager, similar to Cargo in what we have for Rust. And then we have Foundry, similar to how we have for Solidity. And
and this is on the POP network. So if I go to Polkadot.js apps, okay, I can go here. So there is this test Paseo and parachains, right? So it has the Paseo relay chain and all its associated parachains. But currently I'm concerned about POP network. So I just click on the POP network, switch the endpoint. So we are on Paseo network now, and what we need to do is we need to transfer funds using XCM. Okay, so these funds, as I said, would be sent from the contract account, and as you can see up here, I already have 30 Paseo tokens. So now I would just select a receiver. So maybe first let's check some balance. Maybe we can send this to this wallet here, and I just copy the address and I put it as it is 0. Okay, and I paste it here. So this is my beneficiary. Okay, this is the same account which we saw here, correct? And now what is the amount we need to transfer, correct? So our contract currently has 30 tokens. Maybe let's try sending 5. And you can see, right, before even I was entering the amount, we had this something called contract. So I'm calling the contract now, and it would take some time. Oh, do I have an internet? Maybe my internet is not so good. Yeah, so now you can see the wallet that I mentioned earlier. So this is the Talisman wallet, and it's just asking me to, approve this request. So I'm going to approve it, and hopefully this works. So as you can see, the call is successful. But let's check our balance. So as you can see earlier, my account did not have any balance, but now it has 10 Paseo tokens in it. So you can see how with just an XCM instructions, I'm just transferring X, right? But maybe you want to deploy Solidity contracts. So currently on West End Asset Hub, there is this palette called Palette Revive, which can help you do that. So if you are keen on deploying your Solidity smart contracts, Palette Revive is the way to go, and we have provided you all the resources that are present in the Hackathon Bible. And to be honest, West End Asset Hub is not the only place where you can deploy. Polkadot has like 100 plus parachains, and some of those parachains have Palette Ethereum and Palette EVM included in their runtime. So these are also some chains that you can target if you are a Solidity dev. Or if you need something more challenging, maybe write your own custom palette, or make your own roll-up or something like that. And if you have any questions, you can always visit our booth. We are there till the hackathon. And this is the link to the Hackathon Bible, which would be very helpful for you to develop on Polkadot and its parachains. So you can scan this QR code if you need it. Thank you. Does anybody have any questions?
Natively. So here is a takeaway message. This is a win-win for the network, so for Supra, for the consumers, and for the app creators. That's all. Thank you. We will be in the booth. I mean, if there is any conversation you would want to have, I will be available. Our Supra CEO is also here. We can take up there. Thank you very much.
Is it shared?
Yeah, thank you. Shall I start now? Shall I wait like 5 minutes?
Very complicated, cumbersome issue, and there are certain solutions, to be honest. There are some 2.5 solutions in which you can use an RPC, or you can use like centralized providers to get the data, but then you will not be, your application will not be called a decentralized application, because in a way you're storing the data in a decentralized platform, but the way you're getting it to your front end can be compromised. So you need something like the graph, which will in a decentralized fashion give you the data to the front end. So if you simply say what the graph is a middleware between the smart contract and your front end, so that whatever data you're storing inside your smart contract, that can be pushed to the front end using the graph. Okay. Right now, the graph decentralized network has 100 indexers, and if you want to win a bounty, you need to deploy a subgraph on the graph network itself. What is a subgraph? The graph is the protocol, and subgraph is basically your data that you need from the smart contract, right? The graph indexes the blockchain data, but you need to tell that, hey, this is my smart contract address, this is the start block of that particular smart contract address. Please just index this particular data for me. So that subgraph is you telling the graph that in a programmatical language that this is what I need, please get this for me. So this is what subgraphs do. Okay. And if you just want to see how the graph works, you can think of like, okay, so the first in a block, this is the data. With the graph, it can be assembled in a way that you get what you need so that you can query it in the best usable format. Okay. How is a subgraph built? Basically, a subgraph is you first of all write a smart contract, and that smart contract has events, and in that events are being emitted and being
build application. So instead of you deploying a contract on one chain, deploy a contract on n chains, and then whenever there's like a lot of traffic, instead of sending it to one chain, you like spread it across n number of instances, so that your users are paying a minimal gas costs, right? So that thing can be super cool. Then there's just like a general bounty of like pre-execution and composability. Whoever cooks up the
winning. If you build the best subgraph.
That's the basic thing here. We have also a deep dive section provided by them. I'll show you the GitHub repo that is for reference, that you can take for the reference purposes for this, which is an amazing GitHub repo that you'll find useful when you're building for on-chain AI agents. So let me go through the GitHub repo here with you. We have the OpenAI section here. It's taking a little time to load up. So let me give you an overview on basically what it is. As I told you, there are three things. You have to create an assistant, you have to create a message, and you have to then create a thread. So after doing all these things, you will be able to use OpenAI's SDK and then use that to deploy smart contracts and run functions on the smart contracts. So that's how it's going to be useful for you. So due to the internet issues, I'm not able to show you the exact repo right now. But basically what this is there are two sections here. The OpenAI folder consists of all the files that will be useful for building the on-chain AI agent. And then we have the VM. Basically, this is a tool which is used to deploy on Polygon. So the structure.
And I can just directly go and query the sales USD value of.
I have my gaming app, I have tokens in one chain, I have the NFTs in a different chain, and I have special prizes that I want to give to users in a different chain. Okay, and that is where we get our gateway. The gateway you can think about, as VC showed you on the slides, as the glue that connects all of them together. Okay, so here we have a very simple example with a for loop that goes through the counters in each chain, okay, and just increments those counters in the different chains. And here is where you actually make it shine and socket shines, is that you can trigger these actions here in these functions in a asynchronous manner. Okay, we have a way that we can trigger that. You can also revert it. We have here also documentation on that. So since we are triggering things that are asynchronous, how can we make sure that we can revert if some of the actions are not as we expect them to be? Okay, and now just to show you a bit here. So for instance, here we had these, we had these counters here that were, we had these counters here that I just read with this script, which is pretty simple, just to check like what are the values of the counters in these three Sepolia chains, right? The optimism, arbitrum, and base. And when you look at it, it's like we're just getting information from different slots. Oh, sorry. Let me just scroll up a bit. We get information from different slots, and those slots just tell you like, okay, this is what's happening in each state of the chain, and you don't need only to read. You can read and
Ethereum, subgraph slug ETHIndia. It's the ETHIndia token that we are creating today. Arbitrum 1 is the chain that I'll be deploying it on. the smart contract address is this particular address. Let me make sure I copy the right address that I've just deployed. It will fetch the data from ABI of the like Etherscan here. If you are deploying a smart contract which is not verified, make sure it's verified, and then the smart contract with subgraph codegen should be able to get all the data that's required. Okay. In the meanwhile, what we'll do is we'll log into the subgraph studio while the subgraph is getting created. So what I did up till now, I made a ERC20 smart contract, and then I deployed it on Arbitrum chain. Once it was deployed, I did graph init in my local repo and directly copied the smart contract address and let that run. While that's been going on, I've logged into the subgraph studio here, and I'll be creating a new subgraph and name it ETHIndia. Create. Okay, cool. So I've created this account in the graph.com/studio, and here is my subgraph. So the subgraph is created now. Let's go and check this subgraph code out a little bit more for you guys to understand. So if I go here, you will see three most important files. The first is the YAML file, YAML file. The YAML file tells the details like, oh, this is the smart contract address.
The counters, we do have here
to the finished data that is driven over here. You need to map the logic between the raw data to the way it is, like, to the most purest form, which can be queried with GraphQL, and this is the logic that you write for that. Once all these things are already done by the code gen, right? But if you are wanting to win, you cannot directly just do graph code gen and win a bounty. You need to write a better subgraph. You need to write a denser subgraph with more data. Okay, we'll go in that next, but for now, I hope you understood. There is a YAML file for introduction. There is a schema.graphql for the data that the schema way you want to query, and then there is a mapping file so that the raw data can be mapped to the schema file that you need. Once all these things are done, we can just start deploying the subgraph. But here I'm not looking for all the data, I'm just looking for approval event. Like if I approve somebody to get transfers, I'll just need that data. So let's just cancel everything else, just approvals. Everything else is not needed, so I'll just delete that. Here as well, just handle approvals, everything else is not required. Okay, cool. We need to also get rid of this, and yeah, then it should be all good. Alright, the next thing that we need to do is first of all authenticate, right? Authenticate my stuff.
Tutorial by Brian.
Team is here as well, which is the Coinbase developer platform. What we are going to do is we're going to do two things. One, for the larger ETHIndia bounty that we've put, I'm going to talk largely about what it means to be building on base and different aspects of how we've structured the bounty, right? What are things that we're looking for as you're here and thinking about building on base? What are large problem statement buckets to look at? What are interesting use cases for us to evaluate? So that's that, right? And after that, we'll have a technical workshop by a senior dev advocate, Will, who's going to look at that, right? So we have put down a $10,000 large bounty pool. And the idea is to build innovative consumer application use cases, right? What is interesting for us?
Two important things that are in ZK. That is a hash and a field. So currently Plonky 3 now supports these fields and these hashes. So why do we need to do a combination of fields and hashes? Basically depends on what you're trying to do with your ZK circuit. If you want a smaller proof size, if you want faster proving time, you need to alternate, and what kind of a ZK circuit you have. So you can switch and swap between fields and hashes and get the best efficient ZK circuit there. So that's one of the examples for Plonky 3.
The ETHIndia subgraph that I have created.
Plonky 3 we covered. Plonky 3 we covered ZK VM called SP1. These are the old, the whole ZK, the docs for SP1. They're completely very detailed and will help you go through how to set up SP1 packages and how to run ZK circuits there. So this is the most amazing thing out there. You can check this out as well. So after this, we will go through another thing called pessimistic proof. This is also an example, just repository I'm showing. It's something Polygon is developing for the security of the AG layer. It is completely written on ZKVM SP1. So this is one of the examples that we can give you of how to use SP1's ZKVM. Yeah. So after this, we have covered the ZK track. Basically, what we want you to do is, let's just go back and see one of the things that we have done. So there are 3 things you can use now. Plonky 3, we can use SP1, and we can use these 2 things for building our proofs. And we are also like encouraging you to build identity dApps. So how do you build identity dApps? There is something called 2 references given here called Privado and an Aadhaar. There are 2 private identity things that we can use, and we can use these to build proof systems for identity as well. These are also promoted during our
mic is always here, right? There is no alternative.
No.
Okay, all good. It's all good. Like if I cannot walk, then it doesn't matter.
It works.
Yeah. Do I start now? So I guess we can start right now a bit. So yeah, I'm now starting. Hi everyone, my name is Talib. I'm a DevRel engineer at Straya, and we're building something interesting. And in this short session, I'm going to explain like what we're doing shortly, and then what our tracks are, and maybe like how can we help. So the Straya is essentially an EVM compatible ZK rollup on Bitcoin, and like if you're not aware of these concepts, I think first we should dive into what do these mean, and like we can talk more on these. So like blockchains are basically decentralized machines. It's like a combination of multiple machines that does some computation. It's a network of computers at the end of the day. And we're building these because we believe they're a new whole open world of privacy, innovation, and freedom. Even though we failed a bit, like since the launch of Bitcoin, still we believe there's a long way to go, and still we can achieve all these. And if you were to, look back on like how all these things started, like Bitcoin.
There may be resiliency issues, but this isn't the case. Walrus is very resilient. People can still write to the network even if a third of the nodes are down, and you can read the data that you've written to the network, even if up to 2/3 of the nodes are down. So you can see that with our new novel encoding algorithm, we are much more cost effective as far as storage goes than other decentralized networks that have to do full replication, but we're also a lot more resilient than the networks that do other methods of sharding the data. In addition to this, Walrus is also very programmable. Walrus uses the SWI blockchain as the coordination layer for Walrus, and I'll go into detail about this later. But what this means is that storage capacity is now tokenized as an asset and is on-chain to be used in smart contracts. So this opens up a whole bunch of opportunities there. And in addition to the typical delegated proof-of-stake mechanisms, we also have novel algorithms that use to attest the nodes. The nodes can constantly challenge each other to make sure the data that is stored on Walrus is secure and accurate. Okay, so what does it mean when I say that SWI, the blockchain, is the coordination layer for Walrus? Typically, other decentralized storage networks, they have to use some sort of custom blockchain or VM to coordinate all of the metadata and global states for the network. But this isn't the case for Walrus.
Then you basically leave out a bit of decentralization. So it's all these kind of trade-offs, and that's why they call it like blockchain trilemma. But one solution that tries to overcome this at least is not even to the sense that you would think, but it in a different way is rollups. Rollups are types of scaling solutions in which you make a faster and smaller chain, but you also post your data into another blockchain that who can verify your chain execution. It is let's say I make a chain called T-chain and I make it a small network. Then people might be skeptical in the sense that, can these people harm our money? Can these people harm us in the way that steal our funds or whatever? So all these stuff that you see in this event are just kind of scalability solutions essentially, especially if they're infra, who is trying to make a much secure and theoretically much more promising solutions. And one idea is rollups again. And rollups are you make a chain that puts its data into another chain, and as long as this other chain keeps preserving your data, then everything is okay, because you can just use this other chain as a source of truth. And this other chain also has some computation that verifies your execution. It is I make T-chain, I post the data of T-chain into, let's say, Bitcoin, and then I also verify the execution of this T-chain in the Bitcoin as well. So as long as people don't touch Bitcoin or don't break Bitcoin, then I can always verify that everything is correct to the public just using the Bitcoin, so that people can use
that are already being built on Base. In the future,
have to pay for 200 years up front, and there's no minimum size or anything like that. So an epoch in Walrus is a day. So let's say I want to make this available for 10 days. So I can hit upload. And we'll see how fast this is. The Wi-Fi isn't the best, but we'll see. Okay, cool. So we can see the image so the image has loaded here, and we can see that this was newly created, and we get two things back. We get the blob ID. This blob ID is what is used to identify this specific content on Walrus, and I'll show you later that this is the blob ID that you'll use to read this data at any other future time. And then we also have the associated SWI object. This is the address of the object that represents ownership of this picture. So whoever owns this object on the SWI blockchain is the owner of this data and can choose to delete it at any time or also renew its lease and extend it further. And we can see here that this is the epoch that this picture will no longer be guaranteed to be saved on Walrus. Okay, cool. And for those of you who want to go further, let me refresh this. If you go to the docs page, under usage, we'll have the docs for the HTTP API, and you can see how to do all the things that this demo app is doing. So here's a list of all of the public aggregators that we allow to this. So I'm going to show you a demo video of this. So these are all the commands that you're able to run on the CLI. You can read, store, get some information, as well as some other things. So this command will tell us the current information for the network at the time. We can see like the current epoch as well as the cost to upload certain sizes of data. And now we can go ahead and store something. So we'll use the walrus store command. We'll specify the number of epochs, and then we'll input a test file, which is, in this case, it's a text file. So right now the data is being split up and distributed to all of the different nodes in the network.
Important thing that you can bookmark for this and beyond is OnChainKit. And so that's onchainkit.xyz. What's OnChainKit? So been building Web 2, off-chain. You have these toolkits that really help you get up and running quickly without having to go through all figuring out things for hours, days, weeks on ends. OnChainKit is that. And so here on this site, you'll immediately, by using this weekend, are going to have an amazing level up and advantage over people that aren't, that are getting.
And here's a proof for this that you can find on Bitcoin. So we're also publishing this onto Bitcoin as well, so that people can check themselves and see that like everything.
Web portals that allow you to display these sites. And just note that the web portal aspect is decentralized and anyone else can host their own portal. So you're not relying on the Walrus protocol to display the sites. And we've actually seen that in previous hackathons. We've seen other people host their own portals. So at this point, I want to show you an example of Walrus sites. So we have this NFT minting site called Flatland. You can find it at flatland.walrus.site. I can provide the link for this later as well. But so what this is, it allows you to mint a new NFT, and this NFT has a specific shape and color to it. But the cool thing is that each NFT has its own Walrus site associated with it. So this really you can kind of read it down here, but so every NFT has a unique site, and I can show you this here. So I'll mint a new one. Okay, so it just loaded, it just replaced the old one I had here. So we can view the site. So this website is completely specific and unique to the NFT itself. If you go to the NFT on the Explorer, you'll see that it has this purple color and these amount of sides on the shape here. So, and yeah, so this is an example of how you can use Walrus.
So Smart Wallet actually solves this problem. And so I've pulled up smartwallet.dev. This is more of a technical site that you can also bookmark, but it's already integrated into OnChainKit. So you're going to have Smart Wallet as part of your app just by using OnChainKit. And so what Smart Wallet does is you actually don't have to go download an app. You don't have to go install an extension. It uses the pass keys on your phone, your tablet, your laptop to automatically create that wallet for you. So no extension, no installation needed. In addition to that, it's also got capability of what we call a token paymaster. And so that also solves that problem when I was giving that, example of, hey, we've all told people you need to go over here and install this. Oh, you don't have any ETH to pay transaction fees. You got to use an exchange. A paymaster actually lets you set up your app so that transaction fee gets paid for them. And so the reason that's really important is because for most of the world, all of us using things online, we've all gone through this whole like try before you buy, like being able to sign up for something and use it to determine if it's something you want to pay for. Up until just really the last 6 months, that wasn't ever even possible.
Using it and then take some USDT, whatever, these kind of solutions. So because of this, we need cool DeFi ideas. And one track is particularly for this. So, if you have a cool DeFi idea that Bitcoiners can heavily utilize, it's just EVM code at the end of the day. Just try to, optimize it and submit so that we can get use of it, and like there's going to be like there's a bounty for this, and like we can talk even further for it. We support cool builders to make companies and grow bigger as well. And the other one is particularly for Bitcoiners. This is a very specific track using the Bitcoin.
All it's open source. It's also self-custodial, so like there's nothing centralized about it. So this is a great way for you to go in and start saying, oh, I really like this part of on-chain kit. I want to pull that out and use it in my app, or I like all of it, but I don't understand how it works. Go in here to like the template. You can start to reverse engineer some of it. Again, being able to do that compared to people that don't have access to that don't have access to on-chain kit, just because they don't know about it, is going to give you like a 5x, 10x advantage building against a competitor. Really, just, you know, your time is really valuable focusing on actually like implementing your idea and building that community around it, which is the most important part. On-chain kit's going to save you a lot of time there. So the last thing here that I was just going to touch on, we've been through base.org, just high-level overview. Checked out the base.org/ecosystem page for checking out where some of the apps there that are already out there to kind of give you some ideas. Docs.base.org, on-chain kit, smart wallet is this base.org/build page. And so this is one page that you can save, you can bookmark it. It's going to just have everything you need from here all in one place to be on this weekend. Get
Spiling it and then going for MetaMask and then deploying from here. So like this is just the regular environment. So yeah, I guess this is the end of my session, and thank you all for listening, and I hope you all have a great hacking environment and hacking days upcoming. So yeah, thank you.
Today, I was over somewhat near there, a couple hour plane ride away for DevCon, but I really hope that next year we'll get to be there too with you. So if you all have questions beyond this, you want to connect, there's some links on the space.org/build page, also the community link, the socials link at the top of base.org, and most importantly, the Telegram that we have set up for ETHIndia. So we have a specific channel, base channel there, where you can ask questions. I'll be in there. Other team members will be in there, just trying to help support you all this weekend and beyond. So, yeah. That said, thanks again, and thanks, friends. Really appreciate you all being part of this ecosystem and building something better, part of this open internet together.
You can just use Ethernet.
Okay, one sec. I'll plug it in a sec.
All night, all night, all night, all night. We gonna work it all night. Come on. Bend over, let me see you work it. Bend over, let me see you work it. Bend over, let me see. 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 Bend over, let me see you work it. We gonna work it all night. All night, all night, all night, all night. Bend over, let me see you work it. Get it, get it. We gon' work it all night. All night, all night, all night, all night. Get it, get it.
ಬರ್ತಿಲ್ಲ ನೋಡಿ ಕಾರ್ತಿಕ್.
All night, all night, all night, all night. We gon' work it all night.
Is anyone here for this? Is anyone here for this? If not, then I'll just.
It's better we'll check the
laptop the other way.
check. Sir, connect ಮಾಡಿ. ಲ್ಯಾಪ್ಟಾಪ್ ಚೇಂಜ್ ಮಾಡಿದ್ದೀವಿ. Mic check. Hello. Hello everyone. Not audible. Yeah. Hello everyone. They are saying go ahead. No. No issues. No, they have done it. Hello everyone. This is Om from Hurdle01. So.
This one? Lynn? I'm trying to send a message first. Disconnect this really quickly.
No, don't go on screen.
Sorry. Okay.
API, and all of that's super accessible and well documented with TypeScript, and they're TypeScript, with LangChain, and there are LangChain examples with both TypeScript and Python. So depending on your preference as a developer, you'll have either option there. So we can see here kind of a zoomed in receipt of the agent actually doing a transaction on chain. We see this as a huge unlock. So when agents can autonomously do transactions on chain, what does that mean? We're all figuring this out, and it's a relatively new concept, and we're very excited about what you as developers can build to show us what does on-chain autonomy mean in terms of taking action. So come find us by the booth and pitch us on ideas. We'll help you refine them. So if anyone has successfully gotten the template running, feel free to raise your hand. If you do, reach out to me. We also have a Coinbase AI sponsorship. So if anyone wants an upgraded Replit account to Replit Core, that will give you deployment credits so that you can host and deploy your agent, and we can give you that sponsored upgrade here at the hackathon. Just come by the booth and we'll get you set up. In addition to the deployment credits, it also gives you access to kind of the bleeding edge of AI-based programming. So you'll get access to Claude 3.5 Sonnet and OpenAI's GPT-4 Omni. And so you can use that to refine the code inside of your application. I actually used...
which is about a markup of 7,000%. Now, it might be possible that, hey, AWS sets up all this private infrastructure, they have to buy all these land.
We think basically like combining multi-party computation
and create solutions for developers that help solve problems for end users.
for this to almost be like a an equivalent to biological pheromones, at least kind of on like a nature level. This ideally is happening on like a neutral peer-to-peer protocol. There's no specific server or specific like stack that this is tied to. It can just kind of exist like in a way that different peers can interpret this. And so how can we think this, how do we think this sort of thing could help with human connection? If you break human connection down into two problems of basically like discovering connection and then deepening it, we think it can help with both. So on discoverability, like right now, we're basically stuck with like AI algorithms, advertising markets who, show us content or show us different people that we should meet. And these apps and services are often completely unaligned with us in that what they're actually hoping to do is to make you spend as much money as possible and waste as much of your time. And like, they actually do not care about like finding genuine connection for you. In fact, a dating app would rather have you stay on the dating app forever and keep paying them versus actually have you leave. At least like monetarily, that's completely what they're incentivized to do. And so the sort of cryptographic part of this is that on one hand, like we can actually have full ownership of our own data using tools from like signatures and zero knowledge proofs. And as a result of this, like instead of that just going to an algorithm or to these advertising markets, we can control how it's used and interfaced with using tools like MPC. When it comes to depth of connection, like existing social medias and these sorts of platforms for connection, there's no verifiability on anything that happens. It's a common horror story of like dating apps of you meet somebody and they're like completely different from what they say they are because ultimately like you just like say things right now online. There is no sort of like trust or verifiability on this stuff. And in a similar vein, like we operate on most of these in this like billboard model where we just like post things publicly about ourselves. Everyone can see everything. And as a result, we often, instead of tending to like be who we really are, we tend to show off like kind of sanitized versions of who we are and sort of cater to the algorithm. And so in a world with MPC and more cryptography, like first off, you can like these multi-party computation tools I was talking about to basically discover both common and also complementary traits in a way that doesn't need to be mediated through a central service. So I'm just going to go through like a bunch of different ideas for what this sort of thing can enable. I'll skip through a couple of them because we don't have that much time. But the first is the idea of narrowcasting. So this is kind of the opposite of broadcasting. Instead of just putting out information to everybody and hoping an algorithm gets to the right people, you can essentially privately attest to the criteria that you want, like the criteria of person that you want to share this information with. And so this is nice in two levels. One is that the information that you get is almost like guaranteed to basically match who you are and coming from like verified people. And also when you send out information, you can guarantee that it is getting to people who will, it'll be most relevant to. And in this way, we can sort of have information dispersal in a way that's much more like aligned with what we want instead of an algorithm or some sort of advertising market. This is a kind of mathy thing. Another kind of like business angle here is that a lot of this technology enables basically more peer-to-peer connections between businesses and consumers. In particular, like a lot of what I'm describing right now actually is basically just done by Facebook and Google for us. They collect all of our data and they essentially serve as this middleman that connects businesses to consumers by saying, oh, this business wants X person, this person has, these characteristics, and then they just collect rent on this connection making. And, it leads to, goods being priced higher. It leads to, again, like, these things not being incentive aligned with what you want. And so these sort of tools, if wielded more like broadly, could essentially enable this middleman to be cut out and for either users to get paid directly for their data or potentially just for goods to be cheaper as a result of like not requiring expensive ad markets, instead just going peer-to-peer. This is kind of unrelated. Another one that I really like is basically like, at least like in the US where I'm from, like it's quite difficult to connect with grocery lists and like the chores they're going to do in their house or different things they're going to run all publicly somewhere or necessarily all agree on like a single platform to do this. But in a privacy preserving world, you can just post a private commitment to this. You can just broadcast it literally within your like local distance and you can just discover the overlap here. And like it's a very safe way of sharing this because, like you're only going to see what you have in common. So there's lower risk of like judgment or other things happening. I'm going to go through some of the cryptography involved in this. I'm going to breeze through this because I'm not sure what everyone's familiarity with is, but I'm going to be at the PSC booth. It's on the like left side of the main venue, so please come by and talk to me if you have any questions. I'm happy to whiteboard some more stuff. So the first is a tool called private set intersection. This is essentially like kind of the simplest MPC you can do where you discover things you have in common with each other without revealing anything else. And in this case, like something you can do is just like attest to different like interests or like people things you like, and just output the like things you have in common. And it's this sort of like immediate icebreaker. And actually, we've built out a really simple version of this that I'll show you guys how you can use at the end of this presentation. And you can also imagine extending this to more parties. Probably the simplest thing here is just like calendar availability. Like, you just, instead of doing this let us meet every single time, you can basically just post like, here are the availabilities I have, and then just discover what you have in common. And yeah, you never need to like share your calendar with someone else completely. One nice thing about private set intersection or PSI is that it uses privacy offensively. ZK as a tool, for example, is focused on selective disclosure. It's literally focused on revealing the minimum amount of information you can. And so even though it's privacy preserving, it's not very good for connecting with people because you're really actually trying to hide parts about yourself. PSI, on the other hand, like you're basically just seeing what you have in common. So again, there's very low risk of like judgment or some negative thing because it's something you both have, the worst case. It's very easy to understand and explain. I've worked on a lot of different cryptographic apps, and this is by far the one that someone who's outside of our space can quickly grasp and just be like, oh,
yeah, $2,500 bounty, which is about half the 50% of the total bounty. And I wanted to do something different with this hackathon, so I just restricted the AI projects to just these 5 tracks. I don't want any other track. I just want these 5 tracks in AI, and these 5 tracks can be covered in just one day. You can basically code it in let's say 7th December, and they are pretty holistic. They cover a lot of things like live trading, live instrument tuner, and also open source, because I see a lot of people in ETHIndia are open source lovers. If you like to basically contribute into our basically agent, you can clone the repo, go on Gemini, Claude, Grok, Anthropic, into all these LLM providers, and you can make providers of it with compliant to our agent API. And I actually am very excited about this one. If someone can pull this off, and the rest four are pretty easy. You can go through it. And then we have the Unity and the JS SDKs. I've kept these two tracks pretty lenient. And the JS SDK will have these proximity games and open innovation and procedural video visualization and Fall Guy clone. So this is basically the ideas. So Unity and JS is pretty open, but AI I want these only 5 tracks. So that's the ETHIndia hackathon. So yeah, our team will be around if you have any doubts. We will be more than happy to accommodate them. And yeah, that's pretty much it for my presentation. Any questions?
You can keep all of this information private. So the specific salary of the recruiter. So we're still working on Trinity. It should be released like in the next few weeks, and we think it enables really simple DevX and UX. You can build off like other ZK-proven data, like using these Plonk proofs. And the overall API here, essentially, it's very similar to narrowcasting, where you basically can like send an encrypted email to people, and they will only be able to decrypt the contents of this email if they match whatever criteria you attach.
Watch me, baby, as I'm doing my best. My feet are moving to the rhythm, somehow I can't break. I said, watch me, baby, as I'm doing my best. My feet are moving to the rhythm, somehow I can't break. I said, watch me, baby, as I'm doing my best. My feet are moving to the rhythm, somehow I can't break. I said, watch me, baby, as I'm doing my best. My feet are moving to the rhythm, somehow I can't break. I said, watch me, baby, as I'm doing my best. My feet are moving to the rhythm, somehow I can't break. I said, watch me, baby, as I'm doing my best. My feet are moving to the rhythm, somehow I can't break. I said,
There are a lot of back and forth rounds between the parties, but like you can still build some like really interesting POCs with this. And notably, if one of the parties involved in the compute is a server, then the whole like rounds of interactivity And a final shout out to Privacy and Scaling Explorations. This is a sub-team at the Ethereum Foundation that focuses on cryptographic research. We are entirely grant supported by them, and we're incredibly grateful for this support, and it's allowed us to explore very freely. So yeah, that's all for me. Thank you.
version 122, which you can install. We added like a really easy to use Mac OS example and a Ubuntu OS example, which is very very step by step, very easy to go. Don't forget to always add your path here because that will give you like some issues later. And then it's really easy. Our GitHub repo is publicly, so you can download it right from there and quickly build it. Takes like around 30 seconds to 1 minute to build, depending on your internet connection. So that should be fairly quick. One thing is important here is that if you want to have it like readily available throughout your entire operating system, move it to like a location where it can be executed by every user. Goes for Ubuntu, Mac OS, or other operating systems. And then you're basically ready to go, right? So what you need to do here is make sure that you go to our faucet where you can claim some tokens. Very easy. What you do here is, this is not my computer, but I'll show you. Let's see. Oh. There we go. So what you do is you add a Kave to MetaMask. It's all already pre-configured and pre-filled in, so you can just quickly add it to your MetaMask. Always like a little disclaimer, make sure to make like a new wallet address. What we basically do is recalculate like a Merkle tree hash out of that. What we basically do is recalculate like a Merkle tree hash out of that and derive the root CID, so you can access it that way. Just store it on our infrastructure on the blockchain. Now, the reason why I bring this up is that all this interaction from storing data to the chunking to uploading, accessing, creating a bucket, all that information gets stored on chain. So when you, like from the second you start interacting with our network, you will see when you fill in your wallet address here, you will definitely see all those interactions like happen on this level when we get into like the blockchain commands to interact with our network. Around here, very important, keep in mind, if you want to connect on our network, this is what you need. This is the, oh, it's not working, here we go. The connect.akava.ai, make sure to use port 5500. You will see here when you're working on using our CLI, you'll see that all these commands, we call them IPC commands, are used at the end here to use the private key. Let me see if I can show that here. Here we go. That you need to import your private key. Now, if you don't want to see that every time in your execution of your commands, you can 500. And when you spin up the Docker image, if you want application that you're building or downloading software, make sure to host it somewhere publicly so people can access it, because if you run it on your notebook alone, that would be impossible to do from that perspective. Okay. I can take some questions if there are any, and besides that, that concludes the workshop for me. Thank you very much.
advanced developer helper tools, where we have other tools also that you guys can use. You can actually go to this advanced technical reference and go to the status, where we've listed out what are all the different statuses possible, and you can like plan your logic accordingly. Yeah, coming back to the API reference. So similarly, we have calls for transfer NFT and raw transaction execute. So raw transaction execute is of two types. That one is to write to the chain and one is to read from chain. So to read contract data, you use the read contract API, and to execute write on-chain data, you use the execute raw transaction call. So now in the execute raw transaction call, we have two parameters, network name and transaction. And transaction is actually a dynamic object based on the chain that you're interacting with. Excuse me. In case of an EVM chain that is polygon based, the transaction object will only consist of from, to, data and value. And data is the ABI encoded hex value of the contract that you're invoking. And if it is a Solana or Aptos chain, then the transaction object will be for that chain. For example, in Solana, it will be instructions and signers, and in Aptos, you will have function arguments, type arguments, and function name. So this is a dynamic object.
Amore, don't you know? My love, I want you so. Sugar, you make my soul complete. Rather taste so sweet. Me, amore, don't you know? My love, I want you so. Sugar, you make my soul complete. Rather taste so sweet. Me, amore, don't you know? My love, I want you so. Sugar, you make my soul complete. Rather taste so sweet.
When our ideas were trapped with us in caves, we wondered if we'd ever create the world we imagined. We didn't have formulas, but we had vision. We didn't have design, but we had colors. We didn't have canvas, but we had caves. Our tools were imperfect, but our craft was impeccable. Creation has power. When our ideas were trapped with us in caves, we wondered if we'd ever create the world we imagined. We didn't have formulas, but we had vision. We didn't have design, but we had colors. We didn't have canvas, but we had caves. Our tools were imperfect, but our craft was impeccable. We created a world with our craft and spirit, because it's our craftsmanship that distinguishes us. As we continue daring, at home and outside, we stand, we leap, we fall, we stand again, because our spirit is incessant. Because before we are anything, we are artists, builders, creators, because we know creation has power, and we will never stop building. Creation has power. When our ideas were trapped with us in caves, we wondered if we'd ever create the world we imagined. We didn't have formulas, but we had vision. We didn't have design, but we had colors. We didn't have canvas, but we had caves. Our tools were imperfect, but our craft was impeccable. We created a world with our craft and spirit, because it's our craftsmanship that distinguishes us. As we continue daring, at home and outside, we stand, we leap, we fall, we stand again, because our spirit is incessant. Because before we are anything, we are artists, builders, creators, because we know creation has power, and we will never stop building. Creation has power. When our ideas were trapped with us in caves, we wondered if we'd ever create the world. Creation has power. When our ideas were trapped with us in caves, we wondered if we'd ever create the world we imagined. We didn't have formulas, but we had vision. We didn't have design, but we had colors. We didn't have canvas, but we had caves. Our tools were imperfect, but our craft was impeccable. We created a world with our craft and spirit, because it's our craftsmanship that distinguishes us. As we continue daring,
I wanted to just call in to wish you all an incredibly productive and build-filled ETHIndia. We were just in India, in Bangalore, a few weeks ago, and there was so much energy. It honestly blew my mind. The number of crack builders and founders coming together to build sick on-chain use cases left me and my entire team feeling like India is where the world's going to come on-chain. And through that, we had a build-a-thon. We had hundreds of people participate. We gave out 13 prizes to incredible projects. And I was really hoping I was going to be able to make it back here in person, but I wasn't able to. And so I wanted to just call in and say thank you all for being here. Samya is here from the base team. He's here with a bunch of local base builders who are here to help. We're sponsoring a bounty. Hey, everybody, it's Jesse from Base. I wanted to just call in to wish you all an incredibly productive and build-filled ETHIndia. We were just in India, in Bangalore, a few weeks ago, and there was so much energy. It honestly blew my mind. The number of crack builders and founders coming together to build sick on-chain use cases left me and my entire team feeling like India is where the world's going to come on-chain. And through that, we had a build-a-thon. We had hundreds of people participate. We gave out 13 prizes to incredible projects. And I was really hoping I was going to be able to make it back here in person, but I wasn't able to. And so I wanted to just call in and say thank you all for being here. Samya is here from the base team. He's here with a bunch of local base builders who are here to help. We're sponsoring a bounty. And we're hoping that y'all are going to build with us on Base, because we are building a global on-chain economy and we need your help. So if you have questions, find Samya. He's about to come on stage, share a little bit more about the bounty, and I can't wait to see what all of you build. I'm sure it's going to blow my mind. So have a great